we're going to examine one of the great paradoxes of the modern world. You see, we build these complex systems to gather and share information, and we do it because we believe it'll lead to better outcomes. But what if the very act of sharing more information is what guarantees the system will fail?
I mean, it's a belief that's at the foundation of almost everything, isn't it? From how we think rationally to how our organizations and our algorithms work, it all rests on this one simple, intuitive idea. More information leads to better decisions. It feels like the unquestioned premise of progress itself.
And yet, we keep seeing this disturbing pattern. A system gets access to more data than ever before, and then it makes a catastrophic error. An organization has all the intelligence in the world, and it still chooses a path that leads directly to ruin. Suddenly, that core premise looks broken.
So what's the logical response when this kind of failure happens? Well, it's not to question the premise, it's to double down. The thinking goes, the failure must have happened because we had insufficient data. So, the only solution is to add more.
The first thing you can actually observe is the system just grinding to a halt. This state has a name you've probably heard: analysis paralysis. But this isn't a human failing. It's a systemic condition. It's what happens when an overwhelming flood of inputs makes it impossible to produce an output. The system is just frozen.
Let's picture this as a simple physical process. At its core, a decision-making system is like one gear: information, turning another gear: decision. Information comes in and a decision comes out. Input creates output. It's clean, direct, and it works. But remember, the system's response to failure? Add more data. In our physical model, that means adding more gears. The thing is, this added complexity isn't really designed. It just sort of accumulates. Each new source of information becomes another small, unlabeled gear meshed into the machine. And the consequence is immediate and physical. The decision gear, now cluttered with dozens of new inputs, just can't turn freely anymore. Its movement gets sluggish, labored, and eventually it stops completely. The very components that were added to improve its function have ended up paralyzing it.
To see the hidden structure at work here, you have to understand that information really comes in two fundamental types. There's signal, that's the meaningful data, the stuff that drives a correct decision. And then there's noise, all the irrelevant, distracting, or just unwanted data that gets in the way.
And here is the crucial point. The relationship between these two is not linear. As a system gathers more total information, the amount of noise grows exponentially faster than the amount of signal. This isn't a glitch, it's a structural law.
This chart really shows the dynamic. In an early, simple system, the signal is clear and strong. It's easy to pick out from the low level of background noise. But in a mature, complex system, yeah, you might have slightly more signal, but it is completely drowned in an ocean of noise. This state, this low signal-to-noise ratio, is what creates the condition of information overload. And it's not really about the sheer amount of information. It's about the structural gap between the volume of data coming in and the system's capacity to tell the signal from the noise. If we go back to our physical machine, this overload manifests as friction. Those extra gears, most of them representing noise, don't fit perfectly. They start grinding against each other. The system is no longer just paralyzed. It's actively generating resistance and heat. It's becoming inefficient, unstable. Now, a system just can't operate in this high-friction, high-noise state for long. It's forced to adapt. But, and this is key, its adaptations aren't designed to find the truth. They're designed to reduce the friction. So it looks like irrational behavior is actually a necessary survival strategy.
So to cope, the system develops shortcuts. When it's confronted with all that overwhelming noise, it starts to look for patterns it already recognizes. It gives preference to data that confirms its current path and begins to actively throw out data that conflicts with it.
It is so tempting to look at these behaviors, what we'd probably call confirmation bias, and see them as flaws in the system's logic. But from a structural point of view, they're not.
They are perfectly rational, energy-efficient coping mechanisms. I mean, think about it. If you're in an environment where the signal is totally drowned out, the most logical thing to do is to stop listening to everything and start listening only for what you expect to hear. It's a local optimization to survive a globally broken environment. As these coping mechanisms get baked in, the system enters a new phase: lock-in. In our machine, it's like a casing suddenly forms around all the gears. The system is so complex now that you can't remove a single component, not one source of information or noise, without breaking the entire machine. Escape is no longer possible. And this leads to the final state. The heat from all that constant friction literally starts to fuse the noise gears together. They're no longer separate inputs, they're just a solid, immovable mass. And that decision gear, it's now permanently welded in place. The system isn't just paralyzed, its paralysis is irreversible.
So the outcome seems like a total failure. A system that was designed to make decisions can no longer decide anything. But that assumes its purpose was to decide. What if, from a structural point of view, the system never actually failed at all?
This means we have to reconsider its primary function. We assumed its purpose was to make good decisions. But what if its unstated, structural purpose was much simpler, just to gather and share information?
By that measure, the system is an unprecedented success. It has processed, transmitted, and incorporated more information, both signal and noise, than at any point in its history. It is performing its primary function at peak capacity.
So if we accept this new premise, then the catastrophic decision-making, the paralysis, the lock-in, none of it was a failure.
It was the inevitable byproduct of a system perfectly optimizing for its actual goal. You see, a system that is designed to maximize information flow will, by its own internal logic, inevitably drown signal and noise and seize up.
And that leads to the really disturbing conclusion. The broken machine we see isn't broken at all. The disastrous outcome isn't an accident. It is proof that the system is working perfectly,